Hello, my name is Anush Buddetu Pratap Kumar. I'm from Group 3. I'm presenting Fp3 construction. Our group topic is frequent pattern growth strategy. Yeah, coming to the Fp3 representation. An Fp3 is a compressed representation of the input data. It is constructed by reading the dataset on one transaction at a time and mapping each transaction onto a path in the Fp3. As different transactions can have several items in common, their paths may overlap. The more the paths overlap with one another, the more compression we can achieve using the Fp3 structure. Okay, yeah, regarding small size Fp3s, if the Fp3 size is uh, so small enough to fit into the main memory, this will allow us to extract frequent item sets directly from the structure in the memory instead of making repeated passes over the data stored on the disk. Next, coming to the steps involved in the construction of Fp3. Step 1, we have to scan the database and check for frequency of items. Frequency in the sense occurrences of item sets in the database. This step is the same as the first step first step of a priori algorithm. Here, the count of one item set in the database is called support count or frequency of one item set. And we have to sort the item sets in the descending order. Step 2 is actual construction of Fp3. Here we have to create a root node, which is actually null. Coming to the step 3, we have to scan the database again to examine the transaction. Examine the first transaction and find out the item set in it. The item set with maximum count is taken at the top, the next item set with lower count, and so on. It means the branch of the tree is constructed with transaction item sets in descending order of the count. This is the step 3. Next, coming to the step 4, the next transaction in the database is examined. The item sets are ordered in descending order of the count. If any item set of the transaction is already present in one or other branch, for example, in the first transaction, then this transaction branch would share a common prefix to the root. This means that the common item set is linked to the new node of another item set in this transaction. Step 5, as item set count increases, common node and new node count also increases. Yeah. The count of the item set is incremented as it occurs in the transaction. Both the common node and the new node count is increased by 1 as they are created and linked according to the transaction. Step 6, the next step is data mining. Data mining of the Fp3. For this, the lowest node is examined first along with the links of the lowest nodes. The lowest node represents the frequency pattern length 1. From this, the traverse of the path in the Fp3 takes place. This path or paths are called conditional pattern base. Conditional pattern base is a subdatabase consisting of prefix paths in the Fp3 occurring with the lowest node suffix. Next, coming to the step 7, we have to construct a conditional Fp3 now, which is found by counting the number of item sets in the path. The item sets meeting the threshold supports are considered in the conditional Fp3. Step 8, we would achieve a frequent patterns uh, generation in the conditional Fp3. These are the 8 steps involved in the construction. And this is a simple example. I don't want to explain in detail. I'll just explain briefly because Shweta is going to explain the example. We have data set with the transaction IDs and a list of items. The first step is to count the number of items in the database. And we have to, this table here, we have decreasing order count. This is the constructed Fp3 with the first node as null. Here we repeat step 2 to 1 second. Step 3, 4, 5, and 6 will be repeated, and 7 will be repeated until the frequent patterns are generated. And the topest node will be 1 second. The most occurrences, yeah. The most occurrences node, the topest node will be with the most frequency of item sets in the data set. And these are the results. These are the items. We get conditional pattern base, conditional Fp3, and frequent pattern generated. Thank you.